Okay, super quick recap of what we did last week. We learned 3 laws. We did the product law. So if y equals 4x cubed times 6x. Okay, what was the product law all about? So do you remember the rule? We do the derivative of the first times the original second plus the original first derivative of second. So it looked like this, so I'm going to derive this, so 12x squared just times the original 6x plus this keep and then derive that unit. Okay, that was that rule. If there was 3 things, then you just have to alternate, so derive the first, keep, derive, keep, and then keep, derive. Okay, the quotient, okay, so do you remember the rule? Derive, keep, minus keep, derive over the original squared. Okay? So if I derive it, it would look like this. So 12x squared times 6x, the original. Subtract the original, the derivative, over the original squared. Okay, then we did a chain rule. Okay, so here's the chain rule. If we have a unit, instead of just having an x, if we have a unit to an exponent, it's the front times the top, so 1 times 6. 6 of those to the 1 less. Okay, same rule as we did with the power rule. Okay, but this time we have to attach the derivative of the interior unit. And that's it. That's what we did last time. Okay? So somewhere in your notes booklet, I think I have this for you, which is all of the rules written in one page. Okay, somewhere in your notes booklet you have that page. Okay, today we're going to find an equation for a tangent line. Okay, so what do we know from grade 10? You probably don't remember grade 10. So y equals mx plus b, that'll be familiar, right? Where m is the slope, which is rise over run. And the b is the what on the graph? Your y-intercept. Then in grade 10, you also learned how to write linear equations in this form. Does that ring a bell from grade 10? Where x1 and y1 are a coordinate of a point. So if you have a point and your slope, you can use that form. Okay, and then we know the word tangent line. So let's pretend I'm on a curve and I'm here. This would be called the tangent line on the curve. Okay, the tangent line touches it, is it in one spot? And this would be called the normal line. So it would run perpendicular to the tangent. So that's what we're going to do. We're going to get the equation of both of those lines. The one that parallels to it, and then the one that goes perpendicular to it. Okay, find the equation of a tangent line using this curve, and you're going through the coordinate 2, 8. So the first thing is we're going to derive it. So derive that equation, please. 3x squared becomes 6x minus 2. Okay, so that's the equation of the slope. And specifically at the x value 2, what is the slope now? Because I'm at the x value of 2. The slope is 10. That seems good. 10. So which equation am I going to use? Would I use the slope-intercept form or the point-slope form? I'm going to use this equation, point-slope, because I have a point and I have a slope. So I'm going to use point-slope. So the rise is 10, x minus 2, y minus 8. So the number 10 is really like a 10 over a 1, right? Rise 10, run 1. You don't need to write the 1 there at all. Okay, then what is the normal line? So what is the relationship between the slopes of lines and their perpendicular? Does anybody remember the relationship? You did this in grade 10 as well. So if this has a slope of 2/3 per se, this would have a slope of, everybody remember the relationship of the slopes? Well, this is going uphill and this is going downhill. So can we conclude that it will be negative? And you remember that you flip it? Does it make sense? So there's my visual of, oops, I went 3 over 2, and then this would be something like that. Do you see that they're perpendicular? So that's always the relationship, negative reciprocal. Sorry, this was just a different example. I messed it up. I was trying to keep it the same and then I graphed it wrong. Okay, so negative reciprocal. Negative reciprocal. So what is the negative reciprocal of 10? Negative 1/10. And it goes through the same point. So we can do the same thing except for change the slope up. Okay, I'm going to show you what we just did. So you can do this at home. It's called Desmos. It's just a site where you can graph. So our original was a parabola, 3x squared minus 2x. Okay, so there's my original parabola. And we're going to be going through the coordinate 2, 8. Okay, so that's what I want to go through. So we developed the equation 10, x minus 2 equals y minus 8. Did we do it? Did we make an equation of a line that goes tangent through that exact point? Okay, and then we did the same thing with a perpendicular. and then we made a perpendicular line that goes through that point. So that's what we did. So if you ever go graph it, you can see what we did. Okay? Let's try another one exactly like that one. Okay, so find the equations of both lines. So the first step is to derive. So give me the derivative equation. Three x squared minus 4x, that's good. Now, what is the slope specifically at x equals 3? What is the slope going to be? So 15 is the slope. That's good. I'm just going to quickly write down the perpendicular slope is negative 1/15 so that I have them both ready to go. I know the slope of my tangent and I know the slope for my normal line, the perpendicular one. Okay, this question is, however, different than the first one because I don't have a point. I only have an x value, so what's the difference in this question? I now need to figure out what is the point. 3, comma. Where would you like to plug that in? What makes sense? To plug into the original y or to plug into the slope derivative? To get the coordinate of the point, you would plug into the height, the original, right? I got 9 when I plugged it in. Okay, so it's ready to go. The tangent there's your tangent equation and there's your normal equation. Okay, and then on the third question, we'll throw another curveball at you. So this time, I know the equation, but it says find the equation when the tangent line is parallel to this other random line. So somewhere else there's another line, and I want to be parallel to that line. Okay, so I'm going to first derive again. So 2x squared becomes 4x minus 5. If I want to be parallel to this other line somewhere else, what do I know about the slope of my line? What are parallel line slopes like? If you have two lines that you want them to be parallel, what's going on with their slopes? If this has a slope of 7, then mine has a slope of 7 as well, right? Parallel lines should have the same slope. If I had wrote, can I be perpendicular to this one, then you would say you want a negative 1/7. So I need to figure out when my slope is 7. So what do I do now? I would plug in a 7 for my slope and solve for the when does my slope hit 7. Okay, so that's what I'm doing. When is the slope 7? So if I add 5, but do you see how I had to derive first? Because I wanted to solve for the slope. Okay, and I'm still, again, missing a coordinate. So I need the point 3 comma what? And then where do you always plug in to get points? All the way into your original. So always plug into your original to get your point. I got 3. Is it 3, 3? And then, so finding the equation of this tangent line, the slope is 7. And the point is 3 comma 3. Okay? It's not wrong if you write this 7/1 is the slope. That's fine too, but you don't need to write that. Okay? Either way is fine with me.